So we're going to look at scientific notation. Scientific notation is super, super important. Scientific notation is a way for us to express very large or very small numbers. And we do this in part to make sure that we can show the correct number of significant digits, but also it makes it possible to have almost incomprehensibly big or small numbers make some sense. So the mass of the Earth here is this crazy number. We're going to take a look at this number. Now, the decimal for this number would go here. And then there are a whole lot of zeros. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 decimal places that it would move over. So this would be 6.0 times 10 to the 24 kilograms. That's a bit messy. Let me rewrite that because this is really important. It's going to be 6.0 times 10 to the 24 kilograms. And this times 10 to the 24 represents all of these zeros that we've got here, right? These zeros, there are 24 of them, and we've moved the decimal place over that many times. So 6.0 times 10 to the 24 kilograms, this is a massive number, right? If we looked at the mass of a fruit fly, this is an extremely low number of kilograms. And so we're going to show that again by counting these decimal places. So if I move it over 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is going to be 4.5 times 10 to the negative 9 kilograms. And the negative value here expresses that this is a small amount and that those are decimal places that are to the right of 1. And then here, these zeros are creating a massive number, and so they get a positive. So it's 10 to the positive 24. Over here, it was times 10 to the negative 9. And so the rules for converting large numbers to scientific notation: move the decimal to the left until there is one non-zero digit to the left of it. If you do not see a decimal, then it is understood to be the right of the last number. So count the number of times you move the decimal from the original decimal position. This is your exponent n. So 10 times 10 to the n. Large numbers get positive numbers. So if we were going to do this number and put it into scientific notation, so there's a decimal here, and it's going to go 1, 2, 3, 4 spots over. It'd be 4.2. Well, if we were going to round it to two significant digits, we went 1, 2, 3, 4. It'd be 4.3 times 10 to the, we moved it over 1, 2, 3, 4 spots, right? And embarrassingly, I refer to this as like the bum cheek method. I've got like 4 bum cheeks, so it's 4.3 times 10 to the 4. If we weren't rounding it off to any significant digits, it would have been 4.2515 times 10 to the 4. If we only needed 3 sig digs, it'd be 4.25 times 10 to the 4. So this 10 to the 4 is representing the number of decimal places that we moved over to put the decimal in this spot. If we're going to convert to smaller numbers, we're going to again move it over. We're going to again use these bum cheeks, and we're going to go 1, 2, 3, and then we're going to put it here so that we get one number in front of the decimal. It'll be 1.37 times 10 to the negative. In this case, it's a small number, 1, 2, 3, 4 bum cheeks. So 1.37 times 10 to the negative 4. If we only needed 2 sig digs, this would be 1.4 times 10 to the negative 4. Let's get you to do some practice here. We're going to, if you want to pause the video right now, I'll continue going on. If you need to check your answers, you can. So We'll continue. Pause the video now. So we're going to 3 sig digs here, so it's going to be 5.68, and then I'm moving over 1, 2, 3, 4, 5, 6. So 10 to the 6, and here I'm going to have 8.60 times 10 to the, here 3, 6, 9, and one more, so 10. And then here I've got 4.20 times 10 to the negative, because it's a smaller number, 1, 2, 3 to get here, times 10 to the negative 3. This is going to be 4.50 times 10 to the 5. This is going to be 5.81 times 10 to the negative 4. This is going to be 3.60 times 10 to the negative 3. This is going to be 4.50 times 10 to the 3. This is going to be 7.85 times 10 to the negative 3. This is going to be 3.78 times, well, really we don't need the times 10 because this is just 3.78. Here we've got 2.30 times 10 to the, this is 3, 6, and one more is times 10 to the 7. Here we've got 3.47 times 10 to the 1, 2, 3 spots over, 10 to the negative 3.